Kepler's law completed. We have completed Kepler's law, where I had covered Kepler's first law, second law, and third law. Clear? 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 So in third law, what I said, okay, T square is proportional to T square is proportional to T square is proportional to R cube. Clear? Clear? So orbit, okay, R is what? Orbit, radius of orbit. Okay, R is what? Radius of orbit. R is radius of orbit. Clear? On what radius planet is moving, revolving, you have to take that radius and time taken to complete one revolution. Capital T is time taken to complete one revolution. Clear? One revolution. Clear? Keep this thing in your brain. Okay. So what we do, we use this time, okay, for different conditions. Okay, either for different planets. Okay, so suppose we know the time of revolution for Earth, and we want to find out, okay, the time of revolution for another planet in the situation. If we know the radius, if we know the orbit, you can do using this relation easily. Clear? T square, I'm writing equal to here. Actually, this is proportionality. Okay, so T square is proportional to R cube. Clear? 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 So basically, what is this? How you will utilize this in questions? Okay. So what to do? T1 square divided by T2 square equals to R1 of whole cube divided by R2 of whole cube. This is very important concept. Please take care of this concept. Okay, write in your notes. Very, very important. Clear? Up to any doubt to anyone? Clear? Tell me fastly. Can I erase all this? Yeah. So basically today we'll cover, okay, all the concepts. Okay, not related to this, but related to the force. Okay, how gravitational force acts. Okay, for any planet between two heavily, okay, body. Okay, how gravitational force act, how you can calculate gravitational force and numericals and their properties. We do one by one. Okay, I will mention all the points one by one. Clear? Tell me up to here any doubt, any questions comes from here, so you can easily do this. Yes or no? Tell me. And so basically, I already explained what is gravitational force. Gravitational force is simply, okay, if you take two heavenly bodies, there is a force between two bodies. Okay, so that force is simply gravitational force. Clear? Clear? So if there is two heavenly bodies, okay, in a space anywhere, okay, if there is two heavenly bodies, so there is a force between both bodies. Am I right? And that force is what? Gravitational force. Clear? Tell me. Clear? Clear? Up to your any doubt to anyone, tell me firstly. Clear? 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 So if I ask, okay, what is gravitational force? Okay, so if you see two planets, okay, any heavenly bodies, if you see in space, so between heavenly bodies, always there will be a force. Clear? Always there will be a force. Okay, so if you take two heavenly body like this, if you take two heavenly body like this, if you take two heavenly body like this, so there is, okay, mutual force of, okay, gravitational force between two bodies. Clear? Clear? Tell me. Clear? Up to any doubt to anyone, tell me firstly. Okay, so what is gravitational force? What is gravitational force? So force of attraction between any two bodies due to their mass. Take care of this thing in your brain, due to the mass. Okay, so gravitational force is only because of mass. Clear? Clear? Gravitational force is only because of mass. Clear? 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 So suppose if you take Earth, okay, if you take any another planet, okay, so always there will be force of attraction between both bodies. Okay, and that force of attraction is because of the mass of the planet, and that force is known as gravitational force. Clear? 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 Tell me. Up to here, any doubt to anyone? Tell me fastly. Clear? Clear? Yes or no? Yes or no? Tell me fastly. Fastly. So what are the properties of gravitational force? What are the properties of gravitational force? The gravitational force between two bodies form an action and reaction pair, that is, force are equal in magnitude but opposite in direction. Clear? Clear? It's action and reaction. Okay, it's action and reaction. So if you take Earth and Moon, if you take, okay, Earth and Sun, if you take Earth and Mars, Any planet you can take. It's your choice. Okay, there is not any rule that you have to consider only this planet like that. It's your choice. Okay, about which planet you want to calculate the force between in between. Okay, so whenever you calculate the force in between two planets, so what I say, action and reaction, action and reaction. Okay, action and reaction force. Okay, and attractive in nature. Clear? Attractive in nature, and the force will be equal on both planet irrespective of mass. Clear? Clear? Suppose see, suppose m1 is lesser and m2 is like that. Okay, suppose what I say, suppose m1. Okay, suppose m1 is, suppose, okay, yeah. Suppose m1, okay, m1 is greater than m2. It's nothing like that. The force on m1 will be higher compared to m2. Not like that. If for m1 is okay greater than m2, irrespective of that, force between two planet will be equal. And that force is what we already know. Again, I will do today. F equals to g m1 m2 divided by r square. Clear? 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 Tell me. Tell me. Up to here, any doubt to anyone? Ask me. Clear? Tell me. Clear? So gravitational force is action and reaction and attractive in nature, irrespective of their masses. The force will be equal. Clear? Tell me fastly. Clear? Okay. So next what I say, gravitational force between two bodies is independent of nature of the medium. Okay, means gravitational force, okay, do not depend on the medium. Either you are calculating it in a space or in, okay, what do you say? Any medium, you take any medium, it's your choice. Okay, okay. Because most of the time in a space, you can ask that in most of the times in a space or no medium. So why are considering medium and talking like that stuff? But it doesn't matter what I say. Okay, okay, it okay doesn't depend on medium. Clear? It is independent of medium, nature of the medium. Okay, force will be always equal in magnitude and attractive in nature. Clear? Clear? And if the mass is very lesser, okay, if the mass is lighter, okay, in that situation, suppose if you take two ball, so between two ball, okay, force is negligible. Gravitational force is negligible. Clear? Clear? Tell me. Clear? Up to here, any doubt to anyone, you can ask your doubt. Yes or no? Tell me. So gravitational force is appreciable in case of massive bodies like stars and planets. Okay, you already know. I already mentioned. Okay, so it is the weakest force among all the forces, but has the longest range. Very important question comes directly from this. Okay, so see, this is very long range force. Am I right? Wrong or right or no? Tell me. Okay, it's very long range force. Okay, irrespective of, suppose you take Coulomb force, nuclear force. Okay, so all these forces very short range force. Okay, but irrespective of that, gravitational force is long range force. Clear? But as all of you know, nuclear force is very strong to hold the nucleus. Okay, proton and neutron. But irrespective of that, okay, gravitational force is weaker. Clear? Tell me. Very important point I'm giving you. Very important point I'm giving you. Okay, if you are using this point, you can directly solve the questions. Any questions comes in the examination. Clear? Tell me. So another important point is a conservative force. Okay, it's a conservative in nature. Okay, we already discussed all these points. You already know and this take care. Okay, if I ask you, which of the following is conservative force? Gravitational force is the example of conservative. Tell me. Clear? Tell me. Clear? Yes or no? So, what's the mode of communications? Why this force is acting? Okay, if I ask, okay, so what's how it is communicated? Okay, so through gravitations. Okay, so gravitation is because of gravitational force. Clear? And it is okay dependent totally on mass. But obviously, because we are not talking right now about electrostatic force, so it is independent of charge. Tell me again. All the points are important. All the points are very important. Very important. You should know all points. Okay, to solve questions correctly. Clear? Tell me. Any doubt to anyone? Can you solve questions? So gravitational force. Okay. Option 1, force of attraction between the earth and any other bodies. Option 2, force of repulsion between the earth and any other bodies. Option 3, it is the strongest force. And option 4, it is a short range force. Tell me. Don't do mistake for solving these questions. Okay, solve this question correctly. I want correct answer for this question. My screen gravitational force, I've already discussed all of this. This is very easy question for you now. It's a force of attraction between the earth and any other planet. Tell me. Clear? Tell me any dot up to here, any confusion, anyone, it's the strongest force at all, not at all. Okay, it's short range force, not at all. Okay, force of repulsion, whatever, not at all. This is the correct answer. Clear? Tell me. Clear? Up to here, any dot to anyone, any type of confusions. Okay, you can ask me. Okay, you can ask me. Clear? So we already explained this. Okay, so yeah, so you already made notes on this. Okay, so very important, very important point, very important point. Everything is important. Yes or no? Tell me fastly. Clear? 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 Yes or no? So now we already discussed this point. Yes or no? So you basically any questions comes from you, you can easily solve it now. Tell me. Okay. So one more questions. Okay. Do this question. Which of the following is a property of gravitational force? Okay. This question option is it is the weakest of all the forces. Okay. So it has longest range. Okay. It is mass dependent. Okay. And all of the above. Simply you can say sir directly you told all these things are directly you are asking this question. So easy question. So easily we can attempt these questions. So which of the following property is the gravitational force? So sir, this is you already taught this is also correct, sir. This is also correct, sir. This is also correct. So all of the above is correct. Tell me, clear? Yes or no? Tell me. Everything is clear to any dot to anyone. You can ask me firstly. Clear? Any dot. Okay. Any clear? Yes or no? Tell me firstly. So if any questions comes from here, now all of you can do is yes or no. Tell me. Clear? Yeah. We already explained this. Yes or no? We already explained this. Yeah. So we already explained all these things. So you have already notes. Okay, on all this. Yeah. Clear. I talk about universal law of gravitation. So, what's the universal law of gravitation? Actually, universal law of gravitation is that if there is a force, if there is two heavenly mass, okay, the mass. So, what will be? Suppose there is mass m1 here, and here is mass m2. So, there will be force of attraction between both masses, and the force will be proportional to product of m1 and m2. Clear? Product of m1 and m2 and inversely proportional to a square of distance between both masses. Clear? So when you combine both, so it will come f is proportional to m1 m2 divided by r square. Clear? And when you remove the sign of proportionality, in place of that, there will be capital G. You can experimentally calculate the value of capital G. Okay, so 6.67 into 10 to the power minus 34. Clear? So what will be final relation? Final relation is F equals to capital G M1 M2 divided by R square. Clear? Anyone having any type of confusion? Ask me. Yes or no? Tell me. Clear? So what is universal law of gravitation? All of you know. Yes or no? F equals to G M1 M2 by R square. F equals to G M1 M2 by R square. How this relation came? I already derived. Okay, so you should know all these things. You should mention all these points in your notes. Clear? Tell me. Can we proceed? You want points? Okay. So what is the basic idea for universal law of gravitation? So according to Newton, moon is revolving around the earth in circular orbit of radius. Okay. Suppose the radius is r of m. Clear? The moon is subjected to a centripetal acceleration due to earth gravity. Okay. So between earth and moon, okay, the acceleration at am, okay, that centripetal acceleration is v square by r. V square by here rm is the radius of the okay. I already mentioned the circular orbit. Okay, the orbit. Okay, so here you can use directly r, no problem. Clear? No confusion. Clear? So moon is revolving around the earth in the circular orbit of radius r of m. So if you put v will be what? 2 pi rm. Okay, total. If you take the circumference, so what will be distance? Okay, what will be distance? Distance will be 2 pi rm. Okay, clear? 2 pi rm and divided by t. This is what velocity. V square by r. Acceleration is what? Centripetal acceleration. V square by r. Clear? Yes or no? Whole square divided by r. Clear? You can take r of m. Okay, r of m. Clear? Tell me. Clear? Up to your any dot to anyone. Ask me. Yes or no? So yes, sir, no problem, sir. No problem, sir. So from here, what is AM? AM is 4 pi square RM by T square. Okay, you should know this relation. Okay, AM equals to, now finally what is coming? 4 pi R square RM by T square. Clear? Tell me, any dot to anyone up to here? Tell me, ask me. So you can easily know, yes, sir, any question come from yes, easily we can do all this. Yes or not? Tell me. Oh, sir. Yeah. So AM is 4 pi square R of m divided by T square. Clear? 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 Anyone having any doubt? Ask me. Anyone having any doubt? Ask me. So V is what orbital speed of moon? V is what orbital speed of moon? T is time period of moon. So all of you know, moon takes time of 27.3 days. You can take 27.4 also, no problem. So at 27.3 days to revolve around the Earth for completing one revolution. Clear? Okay, and you should know all this data in your brain. Okay, so you cannot avoid, you cannot ignore all this data. Clear? Clear? Tell me. Clear. I already told you Rm is what radius of moon orbit. Okay, on the orbit, moon is revolving around the Earth. That radius is 3.84 into 10 to the power 8 meters. So this radius, no need to remember. You can just remember in your brain that it's nearby 10 to the power 8 meters. If question will come, it will mention in your question. Okay, information will be given in the questions about the radius orbit of the moon around the Earth. Clear? Clear? So when you put all these numerical values, so after solving, AM is 1.63 meter per second square. Okay, you should know this relation. Okay, you should know. You should take care of this relation in your brain. That this acceleration, centripetal acceleration is coming 1.63 meter per second square. So AM is very much less than acceleration due to gravity on Earth's surface G. What is G? What is C on Earth? That is 9.8 meter per second square. Clear? Clear? So this is 9.8 meter per second square. Irrespective of that, this AM is 1.63 meter per second square. So it's comparatively very less. Yes or no? Tell me. Clear? Clear? Yes or no? Tell me. Clear? Up to anyone having any type of doubt, you can ask me fastly. Otherwise, okay, we can move on. Yes or no? Yes or no? So take care of all the values what I had given over here. Okay, take care of all the values. All the values is very important. Okay, so this clear shows that the force of Earth gravity decreases with distance from Earth. Okay, so obviously, if you go up to the above the Earth surface, so what will happen? The force of gravity will decrease. Okay, with distance. Okay, from the Earth. So already we'll see all this relation. Okay, in coming sessions, so don't worry about that. So Newton assumed that this force changes inversely at the square of the distance and calculate the ratio of the acceleration between the Earth and the moon. So what relation came? Okay, take care of this relation. Okay, take care of this relation. So this relation is coming. See, AM is proportional to R, means the radius of orbit, power minus 2. Yes or no? Or if you take G, so if you are calculating for moon, so it will come proportional to radius of moon. Radius of moon means what? Moon orbit. Okay, on the orbit, moon is moving. Yes or no? So that is power of minus 2. And if you calculate for Earth, means capital G, means a small g, proportional, it will come as R of Earth. Yes or no? R of Earth power minus 2. Clear? Clear? If you calculate now G by AM, so RM square divided by RE. Okay, so if you put the values, so what is 3600? It will come 3600. Clear? Tell me, anyone having any doubt up to here? Ask me. Clear? Everything is clear up to here? Yes or no? Tell me. Clear? 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 So any doubt up to here? Anyone? Okay, so finally from here, we created the law that is leads to the universal law of gravitation. So what a distance if you are constructing moon and Earth, so what distance you take on the orbit? Moon is revolving around us. That distance now R. Yes or no? You'll use that. Yes or no? This value is excellent agreement with the value of G 9.8 meter per second, AM equal to 1.63 meter per second square. Clear? Clear? Anyone having any doubt up here? Ask me. So finally, we come to the conclusion. Okay, the universal of gravitation where m1 is the mass of object 1 and m2 is the mass of object. Okay, suppose A and B. So from here you could see the distance R. There will exist between the force of attraction between both the masses. Yes or no? And this force is known as gravitational force. Clear? This force is directly proportional to the product of masses. Okay, F is proportional to m1, m2. Yes or no? Tell me. Tell me. This force must be proportional to square of the distance between the masses. Yes or no? Yes or no? So you combine both relations. So F will be proportional to m1, m2 by R square. Yes or no? Tell me. So what statement will you give? If I ask, universal of gravitation, what statement will you give? So every particle of matter attracts every other particle of matter with the force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Yes or no? Tell me. Tell me. Yes or no? So from here we need to introduce constant to remove sign of proportionality. So result will come F equals to G M1 M2 bar square. Clear? What is G of constant proportionality? Non-universal law of gravitation. Clear? Can you do questions? Lastly, wrap up. Wrap up. Wrap up. Gravitational force is directly proportional to the product of masses. Sum of masses. Then answer all this question. Okay, so what is answer for this question? What is answer for this question? Okay, is a division of mass not at all? Sum of mass not at all. A gravitational force is directly proportional to product of mass. Yes or no? Tell me. Clear? 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 We already completed all this. Yes, or you already know. Yes or no? Proportional to M1 and M2. Clear? So I hope everything is clear up here. Yes or no? Tell me. Ask me. Anyone having any type of doubt, you can ask me your doubt.